We're diving into some really fascinating stuff today. How do we actually get from an architect's initial idea to, those incredible buildings we see and experience?
Yeah, it's a journey for sure. And the materials you've given us point to a process that's, well, it's not always a straight line.
Right. It's more like try, learn, try again, right?
Exactly. And that's what we're going to explore today. We're calling this deep dive Iterative Design and Prototyping in Architecture.
Kitschy. I like it. But let's break it down. So iterative design, what's that all about?
So imagine it like this. It's a cycle of exploration, refining and constantly evolving. Designs aren't just, boom, finished. They're tested, evaluated, and we see what we can learn and improve from each step.
Okay, so it's not a one-shot deal. It's more about feedback, learning, and adapting.
Yeah, you got it. And each turn of that cycle involves some key stages. Well, first, you have to, really analyze the problem. What's the project about? What are the needs? Then you start generating potential solutions, and this is where it gets exciting. You actually build them. Well, not the full building, obviously.
You mean like models?
Yeah, prototypes.
Mm.
And these can be anything from sketches to like full-scale mock-ups. Then we test these prototypes, evaluate them, and that leads to the reflection stage.
So you see what worked, what didn't, and figure out how to make the next version better.
Exactly. It's all about that feedback loop. And the great thing is, you're not aiming for perfection right off the bat.
So you're saying it's okay to make mistakes, to learn from those failures along the way.
Totally. That's where the real breakthroughs often happen. And there are some key characteristics to this approach that make it so powerful.
Like what? Give me the rundown.
Well, first off, it's super user-focused. Because of that testing and evaluation, we're constantly engaging with the people who will actually use the building, getting their feedback.
That makes sense. You want to make sure it works for the people who are actually going to be living or working there, right?
Exactly. And then it's also, nonlinear. You can go back to earlier stages if needed. It's flexible. You're not locked into a rigid path.
Got it. So there's room to adapt as you go.
Right. And the improvements happen incrementally. You don't need to solve everything at once. It's about making small but meaningful progress with each iteration.
Okay, step by step.
Yep. And finally, it encourages experimentation. Trying bold ideas, because even if they don't work out perfectly, they can lead to those aha moments.
So it sounds like a pretty efficient and innovative approach. But is this something new?
That's a good question. And it's interesting because while the formal methodology may be more recent, the underlying principles are not.
Oh, really?
Yeah, think about like vernacular architecture. Those traditional building methods pass down through generations. It's like an early form of iterative design shaped by trial and error over time.
So they were basically prototyping for centuries without even realizing it.
In a way, yes. And then things shifted a bit with the rise of modernism in the 20th century. It became a bit more top-down.
More about finding universal solutions, less about adapting to specific contexts.
Yeah, you could say that. But even then, iteration was still happening, just maybe more internally within the architect's mind.
So what brought us back to this more explicit iterative approach?
Well, by the late 20th century, there was growing dissatisfaction with some of the outcomes of modernist design. And there was a push for participatory design, involving users more directly in the process.
Makes sense, getting input from the people who are going to be using the space.
Exactly. Plus, we can't forget the impact of technology. Digital tools have revolutionized the way we can explore, test, and visualize architectural ideas.
So technology has become a key enabler for this iterative way of working.
Absolutely. Speaking of testing, let's talk about prototypes. What exactly do we mean by that in architecture?
Yeah, good point. It's not like we're building a whole test building every time, right?
Yeah. Right. A prototype can be anything that helps us understand the design better. It could be a simple sketch, a scale model, a virtual walkthrough, or even a full-scale mock-up of a part of the building.
So it's about moving from the abstract to the tangible, something you can see, touch, and experience.
Yeah, and the key is that prototypes are not the final product. They're tools for exploring, testing, getting feedback, and ultimately making the design better.
So what's the real value in creating these prototypes? Why not just jump straight to the final construction drawings?
Well, prototypes let us do things we couldn't do otherwise. They help us visualize the design in 3D, test its structural stability, how light and air move through it, how people might use the space. They're also great for communication, bringing everyone on the same page.
Right, having a shared visual language to discuss ideas.
Exactly. And perhaps most importantly, they help reduce risk. By identifying potential problems early on, we can avoid costly mistakes later. It's much easier to fix a problem in a model than in a half-built building.
That's for sure. Can you give us some examples of different types of prototypes?
Sure, there are study models, which are often small scale and used to explore the overall form of a building. Then there are detail models, focusing on specific connections or construction techniques. Presentation models are those really beautiful scale models you might see in an architect's office.
The ones that look like miniature works of art.
Yeah, those. And then we have digital prototypes, which allow for virtual simulations of all sorts of things like lighting and energy performance. And finally, there are mock-ups, full-scale physical constructions of parts of a building.
Wow, so it's a whole spectrum. And how does all of this fit into the typical flow of an architectural project?
Well, think of it like this. The design process is a journey, and prototyping and iteration happen at almost every step. It starts with conceptualization, where we're just exploring ideas, sketching, making rough models. Then we move into schematic design, where things start to take shape, and we're testing basic forms and layouts.
Okay, getting more concrete.
Yeah. Then in design development, we get into the details. Structure, materials, systems. That's where digital simulations become super important. We use those to refine the design based on performance data. And of course, prototyping continues throughout.
So that's where those more detailed models and mock-ups come in.
Right. We're constantly testing our assumptions, getting feedback from clients and other stakeholders, and making adjustments. We even see VR being used now, so clients can walk through a virtual model of the building before it's even built.
That's pretty amazing. So even after the construction drawings are done, there's still room for iteration.
Yeah, definitely. We have constructability reviews, where contractors might point out potential issues or suggest improvements to make the building easier to build. And then, even after the building is finished, we can gather feedback from the occupants to inform future projects.
So it's a continuous learning process, even after the building is up and running.
Exactly. It's a feedback loop that never really ends.
Yeah.
And it aligns very well with the principles of design thinking, that problem-solving approach used in all sorts of fields.
You've mentioned technology quite a bit. What are some of the specific tools that are enabling this iterative approach?
Well, CAD software, that's computer-aided design, has revolutionized drafting. It allows for quick revisions and precision that were just not possible before. And BIM, building information modeling, is like a supercharged 3D model.
So it's more than just a 3D image.
Yeah, it contains all sorts of data about the building's components. It's like a shared database that everyone on the project can access and work from.
So no more miscommunication between architects and engineers?
Well, hopefully a lot less.
Yeah.
Then there are these tools called Grasshopper and Dynamo, which are used for parametric design. Imagine creating a design based on rules, so if you change one parameter, the whole design updates automatically.
Whoa, that sounds powerful.
It is. It allows you to explore tons of options and optimize the design very quickly. And we can't forget about digital fabrication, things like 3D printing and laser cutting, which make it much easier and faster to create prototypes.
So we can test ideas in the real world much quicker.
Exactly. And then there's augmented and virtual reality, AR and VR, which are transforming how we experience designs.
It's like stepping into the future of architecture.
In a way, it is. Now, thinking about the future of the field, how is iterative design being taught to the next generation of architects?
Right. Are architecture students learning this approach?
Absolutely. It's central to architectural education. Most programs use a studio-based learning model, which is all about that cycle of design, critique, and revision. Students are constantly presenting their work, getting feedback, and refining their ideas.
So it's about learning from mistakes and constantly improving.
Yes. And there are tools like pinups, where students display their work publicly for discussion, and desk crits, where they get one-on-one feedback from instructors. The focus is as much on the process as the final product.
Makes sense. You need to learn how to think critically and solve problems, not just how to draw a pretty picture.
Right. It's about developing those skills that are essential for being a successful architect.
So let's bring this all to life with some real-world examples. What are some buildings that demonstrate the power of iterative design?
Oh, there are so many. Take the Eden Project in the UK, for instance. Those amazing biodomes were developed through extensive prototyping. They used digital modeling to test the structural integrity of that complex design.
It's an iconic structure and a testament to the power of iterative design and technology.
Totally. Another great example is the Seattle Public Library. They used a lot of physical modeling to explore different forms and layouts and to optimize the way natural light enters the building.
It's a really unique and interesting space and a great example of how iterative design can lead to innovative solutions.
Absolutely. And then there are the Serpentine Pavilions in London, which are temporary structures built each year. They're designed and constructed very quickly, so there's a lot of rapid prototyping and experimentation involved.
It's like a playground for architectural innovation.
In a way, yes. And finally, we have the MIT Media Lab's Self-Assembly Lab. They're doing some really cutting-edge research on responsive materials and robotic construction, exploring the possibility of buildings that can adapt and even assemble themselves.
Buildings that build themselves, that sounds straight out of science fiction.
It does, but it could be the future. Now, all of this sounds great, but are there any downsides to iterative design?
Yeah, are there any potential pitfalls?
Yeah, one challenge is that it can be time-consuming and costly. Iteration takes time, and it might not be feasible for projects with very tight deadlines or budgets.
That's a valid point.
And there's the risk of decision fatigue. With so many options being explored, it can be hard to make a final decision. You can get stuck in the loop.
I can see how that could happen. Too many choices can be paralyzing.
Right. And you might also run into resistance from stakeholders who are used to a more traditional design process.
People who prefer a clear, linear path.
Exactly. And then there's the environmental impact. We need to be mindful of the waste generated by creating physical prototypes.
So there are sustainability concerns to consider.
Definitely. But despite these challenges, I think the benefits of iterative design far outweigh the risks.
It's about finding that balance, right?
Exactly. And looking ahead, I think the future of iterative design is really exciting. We're seeing things like generative design, where AI is used to generate design options.
So the computer becomes a design partner?
In a way, yes. And a responsive prototyping, using smart materials and sensors that allow buildings to adapt to their environment.
Buildings that can react to changes in temperature or light.
Yes. And even more sophisticated feedback systems, using data to inform future iterations.
It sounds like the line between the physical and digital worlds is blurring.
It is. And it's opening up some really incredible possibilities for architecture.
So, as we wrap up this deep dive, what's the one key message you want our listeners to take away about iterative design and prototyping?
I think the key takeaway is that this approach is absolutely essential for creating good architecture. It's about embracing experimentation, learning from feedback, and constantly striving to improve.
So it's not just a set of tools or techniques, it's a way of thinking.
Exactly. It's a mindset that can lead to more innovative, efficient, and ultimately more human-centered designs.
And that's a good thing, right? Buildings that are not just beautiful, but also functional and responsive to the needs of the people using them.
Absolutely.
Well, on that note, here's a thought for our listeners to ponder. How can we apply this iterative mindset beyond architecture? How can we use these principles of experimentation and continuous improvement in our own lives, our work, our communities? It's a powerful concept that has the potential to transform not just the way we design buildings, but the way we approach any complex challenge.
That's a great point. I think there's a lot we can learn from this approach no matter what field we're in.